One, we're going to start by naming a pair of corresponding angles. So corresponding angles are the angles that correspond with one another. So an example of that would be angle 3 and angle 7, because angle 3 is above the parallel line and to the right of the transversal. Angle 7 is also above the parallel line and to the right of the transversal. So angle 3 and angle 7 would be a pair of corresponding angles. Then alternate interior angles, those are going to be on opposite sides of the transversal on the interior of the parallel lines. So angle 6 and angle 4 would be an example of that. And then alternate exterior angles are going to be on alternating sides of the transversal on the exterior, outside of the parallel lines. So an example would be angle 2 and angle 8. So I'm going to write that down, angle 2 and angle 8. And then same side interior angles. Same side interior angles can also be called consecutive interior angles. So those are going to be on the same side of the transversal on the interior of the parallel lines. So an example of consecutive interior angles would be angle 7 and angle 4. So that right here, again, I know a lot of kids have trouble with this one. Same side of the transversal inside of the parallel lines, angle 7 and angle 4. Number 2, we're going to find the slope of the line that passes through the points 1, -4 and 3, -5. So to do that, we're going to be using the slope formula. My slope is equal to y2 minus y sub 1 over x2 minus x sub 1. So what I'm going to do is I'm going to go ahead and label these points so that I can plug them into my formula, x1, y1, and x2, y2, and I'm going to plug those numbers in. So y2 is -5 minus y1, so minus -4, and x2 is 3 minus x1, which is 1. And then on the top, we're going to know that when I have two negatives, it becomes positive. So it's actually -5 plus 4, which is -1, and 3 minus 1 is 2. So the slope of the line that passes through these points is -1/2. We're going to identify the slope of a line that is perpendicular to the line above. And then, so we need to remember that perpendicular means the slopes are opposite reciprocals of one another. So an opposite reciprocal means that we're going to change the sign. So this is going to become positive, and then the reciprocal means we're going to flip the fraction. So my new slope, again, change the sign. For opposite, it's going to be positive, and the reciprocal of 1/2, if you flip the fraction, becomes 2/1, which is the same thing as just saying my slope is 2 for perpendicular to this slope up here. They're giving us that line B is parallel to line D, and they're intersected by the transversal T, and we're going to solve for x. So in order to solve for x, we need to come up with an equation. So we want to remember that these angles that are given, x plus 15 and 4x plus 90, these are what we call consecutive or same side interior angles. And we know that consecutive or same side interior angles, they are supplementary, which means we are going to add these angle measures and equal to 180 degrees to solve. So x plus 15 plus 4x plus 90 equals 180. Then we're going to solve for x by combining our x terms first. X and 4x is 5x. 15 and 90 is going to give us 105. Then subtract 105. 5x is equal to 75. And then divide by 5. 75 divided by 5 gives us x equals 15. For these angles formed by the lines, we're going to write an equation that can be used to solve for x. So, and then we're going to solve. So we have actually a few equations that we can come up with from here. So one equation I'm going to look at first would be if I looked at these two. So this angle here and this angle, these two angles form a line. So these two angle measures are going to add up to 180 degrees because this is a linear pair. So I'm going to write that down. These angles form a line, meaning these angles are a linear pair. So I'm going to add those angle measures and set them equal to 180. So I'm going to combine like terms. 9 plus 2x is 11x. Then to solve, I'm going to subtract 15 to both sides. So 11x is equal to 165. Then dividing both sides by 11. 165 divided by 11. 11 goes into 16 one time. 1 times 11 is 11. Subtract and bring down. 55 divided by 11 is 5. Multiplying, no remainder. So x is equal to 15. So that is one equation we can get from this figure. We're going to write another equation. So using two other angles, we're going to write an equation to solve for x. So I'm going to go ahead and look at vertical angles. I have 9x and 6x plus 45. Those angles are vertical, and we know that vertical angles are congruent. So I can set up my equation that way. So I'm going to set that up as 9x is equal to 6x plus 45. Because they are vertical, they're congruent. So then I solve by moving the 6x to the other side. And then dividing by 3. X is equal to 15. And then I'm going to go ahead and show that work. No remainder. So x equals 15. And you should get x equaling the same number in this problem. The flag is shown below, and the corners of the flags are labeled A, B, C, D. The horizontal edges A, B, and C, D are parallel to each other, so they're giving us that A, B, and C, D are parallel. And as are these vertical edges over here, AC and BD. They're giving us that angle BAD is 8x minus 15 degrees. So angle BAD, we'll write in 8x minus 15 for that angle. And then angle CDA is 5x plus 15. So CDA is 5x plus 15. So that's the information that they're giving us. We're going to find the value of x and write the geometry reason for the equation used to find x. So what we want to understand is these are parallel lines, and then this is our transversal. So we're on the interior of the parallel lines on alternating sides of the transversal. So these are alternate exterior angles. And we know, or I'm sorry, interior, because I just said they're on the interior of the parallel lines. So these are alternate interior angles, and we know alternate interior angles are congruent. So to write the equation to find x, we would then take these angles and they're congruent, so we set them equal to each other. So 8x minus 15 is equal to 5x plus 15. And solving for x, go through your steps using your inverse operations. And I get x equals 10 for my value of x. They want us to find the measure of angle BAD and the measure of angle CAD. So the measure of angle BAD, here is BAD right here, 8x minus 15. So I'm going to plug in 10 for x, since I know x equals 10 from step A. And then 8 times 10 is 80, and 80 minus 15 is 65. So the measure of angle BAD is 65 degrees, and the measure of CDA, the angle measure from above, is 5x plus 15. So if we plug in x is 10, which again we got from part A, 50 plus 15 is 65 degrees. We really did not even need to plug in x right here for CDA because we know these angles are congruent. So really, if we knew this was 65, then this one was 65. Number 6, the equation of the line y equals negative 4/3 x plus 6 passes through this point. We're going to write a new equation in point slope form. So remember that point slope form is our equation. And we're first going to write a line, the equation for the line that's parallel. So remember, when you have a line that's parallel, that means they're going to have the same slope. So to write an equation that passes through this point, I'm going to call this x1, y1. I'm going to use the same slope, which is negative 4/3, because they want a parallel line, and parallel line has the same slope. So when I write my equation, I'll be using, again, slope of negative 4/3 and this point that I'm going to pass through. So using this equation, we're going to plug in the point right here, negative 7, 2, for my x1 and my y1, and then I'm going to be plugging in negative 4/3 for m for my slope. So your first y, you write, then y1 is 2. So using the formula, you change the sign. So it's minus 2. That's equal to my slope, which again, I'm using negative 4/3 because the parallel means same slope, use that same slope. And then x is always copied first. And then x1 is negative 7, so changing that sign, plus 7. So here's my answer for the line that is parallel. And now we're going to write a line, the equation of a line that's perpendicular. So remember, the perpendicular lines have slopes that are opposite reciprocals. So I'm going to look at my slope, negative 4/3, and I'm going to change the sign, so now positive, and then the reciprocal is 3/4. I hope I spelled that right. Okay, so we're going to now use the opposite reciprocal of negative 4/3, that's 3/4, as my new slope, and I'm going to continue to use this point, negative 7, 2. So I'm using the same point slope formula. Y always writes first, then when I plug in y1, or y from my ordered pair, change the sign. So it's y minus 2. Then my slope, I'm going to copy down, which is 3/4. And then your first x in parentheses is copied down. And then x1 is negative 7, so in your formula, positive 7. And that's the equation of the line that is perpendicular in point slope form. And then they tell us the equation of line RS. So here's RS. That equation is y equals negative x plus 7. And they want us to find the equation of ST. So we're going to be looking for the equation of this line right here, given that t is at 1, -2. So we're looking for the equation of that line. All right, so since this is a square, squares have these opposite sides that are parallel, and they also have their corners here. These are going to be perpendicular. So the lines intersect, forming a 90-degree angle. So since these lines are perpendicular, I know that my slope for this line that I'm going to create, this equation, has to be the opposite reciprocal of this line up here. So again, I'm going to use this rule that says perpendicular lines, their slopes are opposite reciprocals. So my slope over here, up above, the slope is -1, which is the same thing as -1/1. So when I create my new slope, I'm going to change the sign, so it's going to become +1, and then flip the fraction so it stays as 1/1, which is 1. So my slope that I'm going to use is +1 for my equation right here. So I'll use m is equal to 1, and then I'm going to use my ordered pair, x1, y1, because this line is passing through this point. So using these three numbers, I will use my point slope formula and plug in. So the first y, again, just copy down. y1 from my ordered pair is -2, so I'm writing +2. That's equal to my slope of 1. Copy down your first x, and x sub 1 is 1, so I write -1. So I want to write the equation in slope-intercept form, so I'm going to get rid of parentheses by distributing. Y plus 2 is equal to 1 times x, which is just x, and 1 times -1, which is -1. And then to get y by itself, we subtract 2 to both sides. So the equation of my line is y is equal to x minus 3. Okay, so for number 8, they're telling us that line P is parallel to line Q. Line N is the transversal, probably meant line M is the transversal. The equation of line P is y equals 1/4 x plus 3. So I'm just writing that equation right here next to P. So we want to know what the slope is for line Q. So we want to keep in mind that since P and Q are parallel, that means they're going to have the same slope because we know they're parallel. So if I want to know the slope of line Q, I'm just looking right here at my slope of line P. Because they're going to have the same slope, my slope for line Q is the same. It's 1/4. For number 9, line P is parallel to line Q, and both of these lines are intersected by transversal T. So we're going to find x and then find the measure of the acute angle. So given the angles that they have here, we want to remember that these are corresponding angles, and corresponding angles are congruent. So when we set up the equation, we're setting these angle measures equal to each other. So my equation will be, to solve for x, 4x minus 60 is equal to x plus 15. So to solve for x, we're going to move all the x's together and then the constants together using our inverse operations. 3x is equal to 75, so divide by 3, and x is equal to 25. And then we're going to find the measure of an acute angle. So we're going to choose either one of these measures to plug in x because they're both congruent and they're both an acute angle. So I'm going to choose this angle here, and I'm going to plug in x. So 25 plus 15, and the measure of the acute angle then is 40 degrees. A right angle, they intersect at 90 degrees, or if we look at their slopes are opposite reciprocals. So what I'm going to do is I'm going to find the slope of each of these 1, 2, 3, 4, 5 segments, and I'm looking for the segments that are opposite reciprocals of one another. So I'm going to start with RP, and I'm going to calculate the slope of that. So the slope here is going to be rise over run. So I'm going to start and I'm going to go down 1, 2, 3, 4. So a rise of -4, run of 3. So my slope for this line is -4 over 3. Okay, now let's look at segment PS. So segment PS right here, we're going to calculate rise over run. So again, I'm going to count 1, 2, 3, 4. So down 4 and over 3. So my slope here is -4/3 again. All right, so then I'm looking at this line T, and I'm going to calculate the slope for that one. That is going to be, let's go this way. We're going to rise 1, 2, 3, 4, and run 1, 2, 3. So this slope is +4/3, counting the boxes. And just because one's negative and one's positive, we can't say that these are perpendicular because we want this fraction to also be flipped because opposite reciprocals. So that is not going to be our answer yet. So let's look over here at BS. So BS is going to be this line. Here I'm going to count rise over run. So 1, 2, 3, 4, 5, 6. So -6 over -1, 2, 3. So a slope -6 over -3. Because I went down, it's negative, and left, it's negative, gives me a slope of +2. So a slope of 2 for this segment. And then my last segment is going to have a slope here. Let's calculate. Rise over run. So we're going to rise 2 and run 1, 2, 3, 4. So we went up and to the left, so my slope's going to be -1/2. So just looking for perpendicular lines, we are looking for the angles that form a right angle. So we tried to see if this one formed a right angle, but these are not opposite reciprocals, so they did not. This looks like our next best option. We can conclude that these two are perpendicular because their slopes are opposite reciprocals. So SB or BS has a slope of 2 and BF has a slope of -1/2. So these two are opposite reciprocals, so we know that is our answer. We're going to reflect triangle ABC across x = 1. So I'm going to start by drawing that line of reflection, x = 1, vertical line. Oh, I almost drew it at -1. Sorry, guys. X = 1 would be right here, that vertical line. So I am going to go ahead and reflect this across x = 1. So if I'm reflecting, it's going to flip and land over here across my line of reflection. So A prime, since it's on the line of reflection, A prime is going to land right here on A. So that one is not going to move. It lands on itself. Then B, since B is 2 to the right of my line of reflection, it has to be the same distance to the left. So B prime is going to be 2 to the left of my line of reflection. Then we can do the same thing with C. C is 1, 2, 3 to the right, so it has to be the same distance when it's reflected over here to the left. And I make sure that I label my points. I'm going to draw that triangle. And then I'm going to write down the ordered pair. So we graph the image. There it is. And then we're going to give the coordinates. So the mistake that people make when they write the coordinates is they use the line of reflection. When you write your coordinates, you always start at 0, 0. Start at your origin. So my ordered pair for A prime is at 1, 2. B prime is at -1, 2. And C prime is at -2, 6. So there's your coordinates for your image after the reflection. Number 12, the equation of a line P is given y equals -5x minus 7. They want us to identify the slope of a line, again, parallel to line P. Parallel means same slope. So a line parallel to P would have a slope of m equals -5. Since slope of line P is -5, you're going to use the same slope. Identify the slope of a line perpendicular. Perpendicular again means the slopes are opposite reciprocals. So we'll look at that slope -5 and we are going to flip the fraction. We're going to do the reciprocal of the fraction and we're going to change the sign. So my slope will be a positive 1/5. We change the sign, it becomes positive, flip the fraction, reciprocal of the fraction becomes 1/5. Pat believes that the slope of a line parallel to P, so parallel to this line, is -7. Pat is wrong and explain what mistake is he most likely made, or she, whoever Pat is. What are they doing wrong? So I'm going to say that Pat probably thought that the y-intercept was the slope. So Pat looked at the y-intercept in the equation. So they looked at -7 instead of the slope. And the slope was -5. So we can write down that the number, or the slope, so that Pat doesn't make this mistake again, the slope is the number multiplying with x. So that number that's in front of x is the slope, not the number out here. So he or she, Pat, should have said the slope of the line parallel to P is -5. Okay, because it's going to be the same as the slope there, so -5. Okay, number 13, we're given the figure and we're going to explain why angle EFD is not one of the ways to represent angle 4. So angle EFD is this one, EFD, which is not angle 4. So angle 4 is here. This is not angle 4, and we can explain one of the ways. So let's write that down. EFD does not represent angle 4 because when naming an angle, use points from one side, the vertex, then the other side. Okay, so if we're talking about angle 4, which is what they're going to want us to name next, here's angle 4 that I've highlighted. Okay, when you name angle 4, you use a point from one side, like B, then the vertex, which is right here, E, and the vertex of the angle, and then the other side. So an example of that would be angle BEF. So again, side, then the point in the middle is that vertex, and then a point from the other side. Another way we can name that is angle BEC, again, side, vertex, side. And then we'll just add in a couple more, even though they want two ways, that you can just switch the order and say FEB, and switch the order here and say CEB. But E has to be the number in the middle of the three letters because that is where the vertex of the angle is. Number 14, we are given that F is parallel to G and H is a transversal passing through. Given the pairs of angles below, determine if they're congruent or supplementary. So we will write that down here. So we're first looking at angle 1 and angle 2. Angle 1 and angle 2 are a linear pair. So a linear pair, those angles add up to 180 degrees. Those are supplementary. Those are supplementary angles. Angle 7 and angle 2, their relationship, those are alternate interior angles because they're on alternating sides of the transversal on the inside of the parallel line. So angle 2 and angle 7, we know by that theorem, those are congruent according to our alternate interior angles theorem. Angle 3 and angle 1, those are corresponding angles, and by our corresponding angles theorem, those are also going to be congruent. And then angle 7 and angle 6, those are same side interior or consecutive interior angles. Those add up to 180 degrees according to that theorem. So those are also supplementary. Given that line G is parallel to line H and line H is perpendicular to line J, that's what these mean, just if we need a refresher. This means parallel and this is perpendicular. Okay, so what we're going to do is, given this information, we're going to figure out which one of these three things is true. So it'll be helpful if we draw. So line G is parallel to line H. So I'll draw that. Then we're given that line H is perpendicular to line J. So perpendicular means these lines are going to cross at a 90-degree angle. So that means if this is line J, it's going to form a 90-degree angle with line H because those are perpendicular. So that means that as it continues to go through, these slopes right here are opposite reciprocals, which means these slopes are also opposite reciprocals. G and J also have opposite reciprocals because H and G have the same slope. So this means that G is also perpendicular to line J. So that would be our answer. They also cross here, J and G, at the 90-degree angle. 16, we want to take a note that there was a mistake on the practice test. So before we start, we're actually going to change the measure of angle 1 to 91 and the measure of angle 2 to 89. And so now we're looking at Stephanie measuring angle 1 and angle 2 below with the protractor, found that the measure of angle 1 is 91 degrees and the measure of angle 2 is 89 degrees. So I'm going to write that in just to help myself visualize the information. She concludes that the lines are perpendicular. Remember, lines that are perpendicular meet at a 90-degree angle. Okay, so she's saying these lines are perpendicular. Explain why she's incorrect. So Stephanie is incorrect because perpendicular lines, I'm going to shorten this a little bit. Perpendicular lines meet at a right angle, or in other words, angles are formed at 90 degrees. Okay, so how would the angle measures need to be different so that the lines would be perpendicular? So these lines were pretty close, but the lines would have to be exactly 90 degrees in order to be perpendicular. So each measure would have to be 90 degrees in order to be perpendicular. Anything, even though it's very close, but it's not exactly 90, they're not perpendicular. So changing them to exactly 90. 17, we're given this diagram. We're going to define each of the following terms and then choose an example of pair of angles that satisfy the definition. So here we're given S and T are parallel. So I'm going to go ahead and highlight those. S and T are parallel, and then we have this transversal going through right here. Okay, so alternate exterior angles we will define first. Alternate exterior angles lie on opposite sides of the transversal on the outside of the parallel lines. So we're looking for angles that lie on opposite sides of this transversal, which is here in orange, outside of the parallel lines. So an example of that would be angle 4 and angle 7. Alternate exterior. Vertical angles are the angles whose sides form two pairs of opposite rays. Or a little mathematically incorrect way that I like to say is the angles that are opposite from one another. So if we look back at our figure, we can see two lines, two angles whose pairs of angles formed by opposite rays. That would be this part right here. And vertical angles would be angle 3 and angle 4 because they're opposite from one another. So angle 3 and angle 4. Alternate interior angles are angles that lie on, again, opposite sides of the transversal on the inside, hence the word interior, on the inside of the parallel lines. So we will look on the inside of our parallel lines, opposite sides of the transversal, and we have angle 3 and angle 5. Angle 3 and angle 5 are an example of that. Alternate interior up here. And then same side or consecutive interior angles lie between the two parallel lines and are on the same side of the transversal. So lie between the two parallel lines and are on the same side of the transversal. That would be angle 8 and angle 5. So we have angles 8 and 5. All right. Couple more questions. We are almost given that line P is parallel to line Q and both lines are cut by this transversal T. We're going to write an equation that can be used to find the value of X, and then we're going to justify the equation. So we actually can come up with a couple equations here, but the one that I'm going to look at is these two angles are alternate interior angles, and so these angle measures are congruent. So my equation is 2x minus 30 is equal to x plus 10. And my reason for setting up that equation is because alternate interior angles are congruent. So I'm just going to add in, even though it doesn't ask me to show another equation, but there is a second equation that you could have done. You also could have added these two angles together and set them equal to 180 because those two are a linear pair. So the sum of those angles would equal 180, and that would be another way to solve for x. So now we're going to find the value of x. So I'm going to write down that equation again. And then I'm going to solve for x by subtracting x and then adding 30, and I get x equals 40. And then after that, for part C, we're going to find the measure of one of the acute angles. So remember, the acute angle would be an angle greater than 0 less than 90. So looking here, either one of these two that I highlighted are acute angles. 5x minus 70 is obtuse, so we wouldn't pick that. It would be either of those two. I'm going to choose x plus 10 since that one would be less work. So for x plus 10, I'm just going to plug in x, which I found was 40, and 40 plus 10 is 50 degrees. So the measure of the acute angles is 50 degrees. Number 19, we're going to do the proof. So we're given that M is parallel to N. So these two lines are parallel, and we're given that the measure of angle 3 is 83 degrees. We want to prove the measure of angle 6 is 95 degrees. So whenever we set up our statements and reasons, they filled it in for us here on our practice test, we always are going to start by writing the information that's given. And my reason is given for number 1. Okay, so remember, it's helpful if you write in information on the picture. So we know already angle 3 is 85 degrees, and our goal is to show that the measure of angle 6 is 95 degrees. So that is what we're going to get to. Remember, you don't use that information. You have to show work to get to this as your final step. So this part should be your final statement. Okay, so what we're going to do is we're going to use the 85 degrees and understand that angle 4 and angle 3, because they wrote in the angle 4, we're going to use that. They have a relationship. Angle 3 and angle 4 are a linear pair, so we know they add up to 180. So I'll be able to find angle 4. Once I have angle 4, I'll be able to find angle 6 because they're alternate interior angles. Okay, so the first thing I'm going to do is I'm going to set up an equation for angle 3 and angle 4 without using any angle measures. So we say the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. And the reason for that is that angle 3 and angle 4 are a linear pair. Okay, so we have our linear pair postulate that says the angles are supplementary. Angles are supplementary. So that's my reason for setting up that equation. Okay, so now that I have this equation, I know angle 3 is equal to 85 degrees. So right here for the measure of angle 3, I'm going to plug in or substitute in 85. So I'm replacing measure of angle 3 with 85, so I have 85 degrees plus the measure of angle 4 is equal to 180 degrees. My reason for getting this equation is, or this step, this statement would be substitution. from here, if I wanted to solve for angle 4, I would subtract 85 to both sides, and I would get that the measure of angle 4 is 95 degrees. And how I got that step from step 3 is our subtraction property of equality. We can just write subtraction. Number 5. Now that we know the measure of angle 4 is 95 degrees, we can say that the measure of angle 4 and angle 6 have a relationship, and then we're ultimately going to say that angle 6 is equal to 95. So first thing again is we're going to have to set up the equation or the relationship for angle 4 and angle 6. So the measure of angle 4 is congruent to the measure of angle 6, and that is because they're alternate interior angles, and alternate interior angles are congruent. Whoops. Alternate interior angles are congruent. That's how we were able to set up this right here. So now I know again that angle 4 is 95 degrees. So I'm going to plug that in right there for the measure of angle 4 using substitution. So 95 degrees is going to equal the measure of angle 6. I plugged in that 95 right there for angle 4 because I know the measure of angle 4 is 95. And this is using, again, substitution. And this is what we were trying to prove. We were trying to prove the measure of angle 6 is 95 degrees, and that's what we just proved. So